Hey guys, how's it going? This is Siri and I'm back with another PyTorch video, and today we're going to be focusing on tensors. And so when I'm going to be talking about tensors, there's going to be like a series of videos. So I'm not going to cover everything about tensors in just this video because there's a lot to cover, but we will go through an introduction and we'll talk about like why we need them and how we can initialize tensors with a few of the most common default values, so that you can change them afterwards. And and just using like dot shape and using lists to, like, starting out with lists and then converting them to tensors. Okay, so first of all, tensors are one of the most, if not the most important part of deep learning. I mean, I guess you could argue that the different layers and the components that make up the neural network are important too, but without tensors, none of that's going to happen, because you need a way. I can't stress this enough. I've reiterated this like multiple times throughout my previous videos, but your model, which is just a mathematical web, needs to take in information that it can understand. It can't understand colorful images that you can understand. And so you need to convert that to numbers, and you need to convert that into numbers which are stored in a good data structure. Like, you have data, you have numbers, okay, so what? You need a good way to store it, and tensors are that way. Okay, tensors are multi-dimensional arrays, and you, just for naming purposes, I've covered this in my other introductory tensors video, but so like if you have a 1D tensor, that just means you have a regular, I mean, it's not a list, but like you have like a string of numbers. And when I say string, I'm not talking about a Python string or like anything in closing quotes. I'm just talking about numbers, okay? Like you have like a series of numbers, okay? And that's just 1D. It's one-dimensional, right? In math or like in daily life, right? 1D is just a line, right? And 2D is if you have two lines, right? Like a height and a width. And so that would be a matrix. Okay, a 2D tensor, a 2D tensor you would call a matrix, but a 1D tensor you would call a vector. And remember, a vector is just a 1D tensor. Once again, it's a series of numbers, and usually if you were using that vector to, you may be familiar with it this way. Like if you use vectors to represent a point on the coordinate plane or like a 3D coordinate plane, you might be familiar with that, with vectors in that way. But a vector, a 1D tensor is a vector. Okay, so, and anything above, like you would call all of these tensors, but there's no specific name for anything that's 3D and above. 3D tensors and higher dimensions, you would just call regular tensors, right? Okay, so yeah, that's that. Okay, great. Okay, and so we are talking about transformation here, right? We have, we can deal with multiple different types of data. We can deal with audio data, video data, paragraphs, and whatever, but in this series of videos, I'm going to be just focusing on images. Okay, so we need to convert our data into numbers because that's the foundation for any computation and any like analysis or anything that you want to do on computers. You need numbers. And so features are also determined using the commonalities the model finds in the number representation. So if you have an image, right, and you represent that image using numbers. So for example, each pixel might get like a different collection of numbers, right? So RGB or RBG, right, like for the different colors, and like whatever. Okay, so but your pixels are represented using numbers, right? So features are the patterns that you can detect. And patterns, I know patterns is a bit vague, but it's in a mathematical sense. Although when you translate it directly to what the image is, they are patterns, right? So edges and like the center, or like the different curves or the lines in the image, right? Although the model doesn't see it as lines, that's what it's representing and that's what it's doing. So if you see some patterns within these numbers, then you find features, right? You find those patterns in the image or in like paragraphs or whatever, right? So the data structure that we use to encode and represent inputs and outputs of our model, which again is a mathematical web of different computations whose aim is to, get a specific output given an input. So f of x is equal to x plus 2. You're passing in 3. You're hoping to get x plus 2. And then the output that the model outputs is 5, right? Because 2 plus 3 is 5. It's something like that. Similar in nature to that, but a little bit more complicated. Okay, so yeah, and what is that magical data structure that we're talking about that is used to encode this information? Well, they're tensors, right? So I think I should write here that they're multi-dimensional arrays, right? Okay. And remember, at the end, you're going to need to decode and convert that tensor back into the image that you started with, right? So remember that that's another important step at the end. And our model, okay, another important thing to note is that our model doesn't need to do this entire transformation in just one step, right? It can do it in multiple steps. It can, first, it does it in stages and it does it in parts. And so, for example, if you have an image of the beach, right, it doesn't analyze the entire image at once, obviously, right? If you have like a burger in front of you, or if you have like a pizza in front of you, you don't put the whole thing in your mouth, right? You eat it in different parts, right? Different bites, rather. So first it might start off with the edges, right? Not only are these different features, but they're also processed at different times. And so maybe first, like the edges, and then next maybe it'll move on to the sun, which is in the beach, right? The beach image, and maybe the ocean and other key components that characterize the beach. And so you can call these outputs of each of these different stages an intermediate representation of the image in numbers, obviously, that describe how the inputs are matched to the outputs. Okay, so you have different stages, you're characterizing different or you're looking at different components of the image at different times, and each of these different parts are intermediate representations, and and the deeper you go into a neural network, it'll detect more complex and more precise structures in your image. So what do these computations look like? Exactly. Well, you combine your inputs and the previous layer's weights, okay? And when I say layer, or module. I just mean a collection of computations that a specific part of the model will perform on the input tensor. And remember, your inputs are going to need to be converted to tensors, because that's the way we represent this data. And so these different layers or modules, they have different chunks of the computations, and that are going to be applied on the input tensor. And so once we apply a series of computations or series of operations on the input tensor, we and what we'll learn is that this is actually in hopes of updating the model's parameters. And so this won't seem so magical once we go on to talk about what each of the different layers do and why we're doing this. But first, we're just focusing on how this data is represented. That's the main focus for this video and for this topic. And so we need a way to represent this data, and tensors are the way to go, okay? So they can have many dimensions, like I said, 3, 4, 5, many more than that, right? Okay, considering the complexity of the computations. And although the data may have reasonable dimensions, right? Considering that matrix multiplication that goes on in the network, it's not surprising that there can be hundreds and thousands of dimensions to your tensor. So, and just to note, the number of, first of all, this is an array, right? Multidimensional array, and the object is a tensor. And so, but it basically acts like a list, or a Python list, or an array. And you can index them the same way. You know how if you have a Python list, right? If you say, like a grocery list, and remember, we're not going to be doing any of this in tensors, using tensors, because we can't have strings, right? Even though you can have it in your input data, we're going to have to find another way to encode it. But if you see apples, oranges, and pears, maybe, instead of grocery list, maybe let's just say fruits. You can index them. You can access these different elements. You don't need to access them all at once. You can access each individual element, whichever one you want. So for example, if you want to access the second element of your list, your Python list is just a regular Python list. Okay, if you want to access it, you're going to say fruits. And since it's a zero-based index, you would have 0, 1, 2. So let's do 1, and you run it, and then you get oranges. Okay, the same way. And if you have maybe let's change this to a grocery list. Okay, so maybe the first list inside the list is fruits, and maybe the second one is the other items that you might need. So milk, maybe you want to but maybe I don't know, waffles, the frozen ones, syrup, yogurt, whatever. Okay, so now grocery list 1, you get the entire list. You get the entire second list. So you're going to have lists inside of lists, and that's what I mean by multidimensional arrays. So inside inside grocery list, we have 2 elements. I know it seems like a lot of elements, but we actually only have 2, right? And you probably know this if you're familiar with Python, which I'm assuming you are, considering you're on PyTorch already. But yeah, you have 2 lists. And so if you want to index the second list and you want to get waffles, or if you want to get yogurt, maybe, you would say 0, 1, 2, 3, and 3, and then you just get yogurt. Okay, so same thing applies to tensors. Okay, so the number of indices that you provide shows the number of, well, assuming that you're only accessing one element, because if you're not, then you can get the whole list, right? But assuming that you're only accessing one element, the number of indices that you provide are the number of dimensions in your tensor, okay? Or of your tensor, okay? So, yeah, that's just because of the definition of an index and like the way this works. Okay, so many other libraries also deal with tensors. Okay, PyTorch isn't the only one, and like everyone uses tensors, or like the other libraries use tensors for the same purpose, like data representation and computation. I would say the most popular library for multidimensional arrays is NumPy. And NumPy is a popular multidimensional array library, and PyTorch has capabilities to work with and interoperate and work nicely with NumPy. Because you can't, it would be rare to find a place where, not rare, but like you find wherever you are dealing with multidimensional arrays, especially in scientific computing and machine learning tasks like this, you're probably going to see NumPy somewhere, okay? And it's common. And instead of reinventing the wheel, PyTorch offers you the option and the ability to work with NumPy. Like, you can use PyTorch and NumPy at the same time. And so what do I mean by that? Well, you can convert between the two. You can convert between a PyTorch tensor and a NumPy ND array. So you can do some conversions there, and it works well, okay? And some other stuff too, okay? And this makes it so much easier to work with other libraries, like Pandas, SciPy, and scikit-learn, because you'll probably never see some code or an application that uses Pandas and doesn't, or like these other things, and doesn't use NumPy. Okay, it's very common, and so it's great that PyTorch has this interoperability. It interoperates with NumPy nicely, okay? So there are a few differences though. Like, why not just use NumPy ND arrays then, if they're so similar and they can interoperate nicely with each other? Well, there are a few key differences that make tensors the most favorable to use, especially in deep learning. And so, in deep learning. Okay, so a few advantages include accelerated computing on GPUs. Okay, parallel processing. Okay, which just means doing the computations on multiple devices, right? Because it takes a lot of computing power to, especially if you're dealing with a data set that's like thousands and thousands, or maybe even hundreds of thousands of images, right? Maybe usually it's thousands, but okay. Yeah. So what am I talking about right now? I'm talking about the advantages of tensors. Okay, so accelerated computation on GPUs. And GPUs are just graphical processing units. Makes the computations a lot easier. It's a lot more power. And it also keeps track of different computations, which is going to be extremely helpful during optimization, which just deals with the gradients and derivatives and, optimizing the parameters, which are just the different pieces of your computation, right? What you're multiplying it by, what you're adding it by, what you're taking the exponent of, right? There's so many different complicated like computations that you are going to be, or not you, but the model is going to be applying on your input. And so it's important to keep track of it so that you can take the derivatives of each of the different steps so that you can decrease the loss, or in other words, decrease how wrong your model is. So it's going to improve the accuracy a lot. Okay? So, yeah. So let's just talk about the basics of a tensor right now. It's just an array, right? And not all, but most of the time, it's going to be a multi-dimensional array. And it just stores a collection of numbers, like you probably guessed, right? And what I've been talking about. And you can use it, you can access it using an index, like I've mentioned before. And I gave you this like grocery list as an example. So the number of indices are how many dimensions there are if you are referencing a single element. Okay, and yeah, so this is how Python lists work. So what about tensors? Well, first we are going to need to import Torch so we can use all the great stuff PyTorch has to offer us. Import Torch. Okay, and Python lists are great, but if you want to express more complicated things like images, time series, and even sentences, right? Imagine encoding a full sentence as a number, right? But that's what we have to do if we're doing stuff with deep learning. But if you want to express these different complicated things, you're going to need tensors because Python lists aren't going to cut it. And so you need a much more efficient and clean way to represent this data. Sure, you have nested lists, but how many times are you going to do this, right? It's very inefficient. So let's set A equal to torch, right? And then ones. This is what we call a factory method, and factory methods are just methods that you can use, which are related to tensors. Okay, and you can initialize the tensor. You can initialize this multidimensional array with default values, and you're obviously going to change it afterwards, right? Default just means like it's a starting point. That doesn't mean you need to. Actually, it most often means that you're not going to leave it like that, right? It's just an initialization. Okay, so A is equal to torch.ones, and you need to specify the dimensions inside the parentheses. So that's what the argument is going to be. And so since I'm only providing one number, this is going to be one-dimensional, and this is going to have 3 elements. And so if I print out A, we get 1, 1, 1, 3 elements and 1 tensor. Okay, 3 elements, 1 dimension. That's what I meant to say. Okay, and if we print out the shape, right, we'll get the dimensions, and it's just 3. Okay, by the way, a cool little trick is that if you want it to be a matrix, or if you wanted to add a dimension of 1, although it doesn't add anything, add any value. It does add value, because people do it for a reason, but it doesn't actually change the elements, right? So, but if you just wanted to add a 1, instead of just 3 elements, if you want it to be 3 by 1, you could do unsqueeze and then specify the dimension along which you wanted to add that extra dimension. So if you want it to be 3 by 1, then the 1 is in this second element, so it would be index 1. So now the size is 3, 1. If you were to put it at the 0th index, it would be 1, 3. Okay, cool little trick. That's what unsqueeze does. Okay, let's just copy that here, but let's just leave our tensor like that. Okay, so yeah, that's A, and that's our new A. Okay, so you see the extra pair of brackets here. Okay, it's only 1, but here it's like you have one tensor and then you have a tensor inside of it. So yeah. Okay, cool. And what's the type? You guessed it. It's gonna be a tensor. Okay, torch.tensor. It's an object, right? Okay, and what you can say is that, okay, first of all, this is let's call this B. Okay. So what we have for A is a single element tensor. And so what you can do is that you can just convert it to a regular integer. Why? I mean, if you wanted to keep it as a tensor, you could, but if you wanted to convert it to a floating point decimal or just like a regular integer, you can do that as well. So if you do float and then A, one sec. Oh, this is not one element, right? So if we just say 1, so that's one element. So now it'll work. So you see, A is 1.0 now. So here it's a tensor, type tensor. But here, if you do it again, it's type. Okay, this doesn't do it in place then. Okay, so okay, so it's still a tensor. Okay, never mind that. Okay, so yeah, it can be converted to a Python scalar if you wanted. Okay, so A of 2, let's turn this back to 3. What if we did B of 1? Oh, we did unsqueeze. Okay, never mind. Never mind. Okay. All right. So, yeah, so if you want to do something with Python multi-dimensional arrays, it's not going to work out considering the scale that you want to do it at. So that's why we need tensors. And we'll talk about why they're so much better when we get to talk about how they're stored in memory. So using like different storage instances, it's another object, which we'll be talking about in our in a future video in this like tensor series of videos. Okay. And if you wanted to initialize a tensor because you knew how many dimensions there were, then you can use PyTorch's tensors factory methods, including zeros and ones. So if you wanted to initialize this with zeros, then it would be full of zeros. And this is just a placeholder, like I said. Okay? And slicing is also applicable to PyTorch tensors. So if you have my list, okay, is equal to a list, and let's pass in a range object, okay, of 10, range 0 to 9, actually, because I think 10 is excluded. Let's print an empty line. And let's have some part of your list. Actually, yeah, this is going to be some part of the list. And it's quite ironic because I'm actually going to print the entire list. So my list, so if we have that, some part, actually this is just a Python list, so let's convert it to a tensor, because that's my whole point, right, that you can do the same sort of slicing with tensors. I mean, we could import transforms, but torch.tensor, let's pass in my list. And let's print out, okay, so this is my list 2, and let's just print out my list 2. Okay, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now some part of my list is going to be the entire list. So we can print some part, okay, which is basically the whole thing. And maybe if you wanted 1 to 4, which is actually from the second element, which is index 1, to the next one. So it's only going to be 2 elements because it stops at 4, because 4 is exclusive. So if you printed out some part, you would get, oh, I was wrong. 1, yeah, it ends at 3. That's what I meant. So it starts off at 1, starts off with the second element, like I said, and then goes on to element 3. So 1, 2, 3. Okay. Okay, yeah, so tensors, you can apply slicing to tensors like that too, if you want. Okay? Yep, that's actually it for this video. So in our next video, you can look forward to some broadcasting and how that works, and how we do that with PyTorch, and we'll look at some more arithmetic operations, because I don't think we've looked at that yet. And yeah, so today was just a gentle introduction, like about why we need them, why they're so important, what they are, and how they're kind of similar to Python lists, except so much better because they're so much more efficient. Okay? Yep, that's it for this video. Thank you so much, and don't forget to like, comment, and subscribe. Bye.